Greetings everyone. Today we're going to explore GCF. That stands for Greatest Common Factor. And what's nice about this is you should have had an introduction to this in previous math classes, so hopefully some of this is a review. For this lesson, you'll want to have your foldable. Please make sure at this time that your foldable has your name on the front. Because they're all the same color, if one is left behind, I want to make sure I know whose it is. Please make sure it's folded in this order so you can see all the tabs. And if you're absent, now is the time to find that foldable somewhere in the classroom, ask a neighbor where the extras are, and please pause the video so that we're ready to go. Let's open our first tab that says factor. What does it mean on the bottom? On the top half of the foldable, when you open that front flap, please pause the video and jot down this information and then press play again when you're ready to do the examples. All right, let's go through this top half of that first page. Let's talk about distribution. Distribution involves multiplying each term in a grouped series of terms by the term on the outside of the grouping. So we've already been distributing in different ways, but now we're going to have increasing exponents, different types of variables, and so we really are going to get pretty involved. So let's work on example 1. I have a term on the outside, and I need to distribute it to every term on the inside. Now you don't have to write this piece down, but what that means is I'm going to have a 2x times x, a plus sign, and a 2x times 8. My hope is that what I just wrote down we can think of mentally. If I have a 2x times a 1x, I have a 2x squared. Remember, when multiplying bases, we add the exponents. So this is different than adding and subtracting. We're multiplying, so be careful. I then have a 2x times an 8, which is a 16 and 1x. Let's take a look at example 2. In this example, my term outside happens to be on the right side. That shouldn't change anything. I'm still going to distribute it to every term on the inside of my group. So again, I'm going to write it out. I have a 5n times n and a positive 7 times 5n. The order in which I multiply does not matter. So if the 5n's in front or behind, doesn't change a thing. 5n times n is 5n squared because we add these ones. 7 times 5n is going to be 35n. Example 3. Here you'll notice I have a negative and 3 terms to distribute. Okay. Now we're getting to the point where I don't want to show my work because it is a lot to write. So let's talk this through. I have a negative 3c times a positive 8. A negative times a positive is a negative. An 8 times a 3 is a 24, and I have 1c value. Let's look at the next term. I have a negative 3c times a positive 2c. A negative 3 times a positive 2 is a negative 6. C times c, c squared. This last term I'm going to put a 1 in front. That means I have a negative 3c times a negative 1c cubed. If I have a negative 3 times a negative 1, that's a positive 3. And a c times a c cubed, well, if this has an exponent of 1, I now have an exponent of 4. Remember, when multiplying like bases, you add the exponents. All right, let's take a look at the bottom half now of that same page. For factor, what does it mean? Let's talk about what it means to factor. First, to find out what was originally multiplied to create the expression. That's what we're going to do. We're going to find out what was originally multiplied. Or to explain it more generically, we're undoing the multiplication process. So if we consider those previous examples, we were multiplying it in. Now we're going to divide it out. Dividing is the opposite of multiplying. All right, let's flip to the next page in our foldable, the page that says Greatest Common Factoring GCF. Let's take a look at the top half that is currently blank. We're going to write one piece of information. What is greatest common factoring? So you'll have lots of space to write this on the top half. Greatest common factoring means what is the largest number and or variables that can be divided out of each term in the expression. Please pause this video, write this down, and then we'll look at it again. Okay, take a look at the name, GCF. Greatest means we're looking for the largest number. That's why there's going to be a lot of numbers we could possibly divide out, but I want the largest, the greatest number. Okay. Common, meaning it has to come out of each term. So if I can't divide it out of each term, they don't have it in common. And we call it factoring because we're dividing out. Okay, we're undoing the multiplication process. You don't need to jot this down, but let's just talk about it. If I look at these combinations of numbers, which pair of these numbers has the greatest common factor of 4? Well, let's take a look. What's a number I can divide out of 4 and 5? That would only be a 1. I can't divide anything else out. 4 and 6 have a GCF of 2. Now careful, they have a common factor of 1 and 2, but the greatest common factor is 2. So let's do that. Common factors of 8 and 12. Well, 1 goes in, 2 goes in, 4 goes in. Those are the only numbers. So the GCF, greatest common factor here, is the largest one, which is 4. Let's talk about why the next one's not true. 8 and 16 have a common factor of 1, 2, 4, and 8. So its greatest common factor for this set of numbers is 8. So it doesn't mean which ones do 4 divide into. It means which set of numbers is for the greatest common factor. So be careful, that G, that greatest idea means a lot. Same idea, but now what if I ask for a 4x? Okay. Well, same idea. Common factors of 4 and 5 are 1, and common factors of x and x are x. That's it. So the greatest common factor here is 1x. Common factors of 4 and 6, again, were 1 and 2, but we have x's, so it's a 1x and a 2x. So its greatest common factor is 2x. Common factors, again, would be a 1, a 2, and a 4 with x's. So greatest common factor of this set of terms would be a 4x. Common factor here again, 1, 2, 4, and 8. But because they both have x's, I can divide an x out. But the greatest common factor would be an 8x. So all I'm stressing here is that if you have a like variable, that needs to be part of your GCF. Okay, so in this case, again, my greatest common factor of 4x would be that third set of numbers. Now let's take a look at a polynomial. Again, don't have to write this down. I always separate it out into look at the numbers and then look at the letters or the variables. So in this case, I'm going to look at the numbers first. I have a 3, a -9, and a -12. So out of 3, 9, and 12, I can divide out the following numbers. I can divide out a 1 and a 3. Oh, that's it. Those are the only numbers I can divide out of 3 and 9 and 12. So my greatest common factor is going to have a number of 3. Now notice they don't all have negatives, so I can't take a negative out. Let's look at our letters. I have 4 x's, I have 2 x's, and I have 1 x. So the only thing I could divide out of all 3 of those would be 1x. Okay? I can't take 4 x's away from 1. That wouldn't work out. Okay? So my GCF is going to be a 3x on this problem. All right, let's take a look at the bottom half of your foldable and work on some of these examples. First thing I want to do is decide my greatest common factor. So on example 1, greatest common factor, what can I divide out of 6, 12, and 18? Well, look at the smallest number first. Does 6 fit in to all of those numbers? It does, so I can divide a 6 out. How about a variable? Can I divide an x away from everything? I can't because that 18 doesn't even have an x. So the only thing I can divide out is a 6. Now I need you to actually divide them out. So we're going to divide every term by the GCF. So divide by GCF. We're going to leave that 6 hanging out on the outside. We need that. And we're going to start a parenthesis of what is left over. So if I have a 6x squared divided by a 6, I have a 1x squared. If I have negative 12 divided by a positive 6, I have a negative 2 with my x left over. If I have a positive 18 divided by a positive 6, I have a positive 3. Okay. Now when I look at that, the numbers got smaller, which is good, and they're all still integers. Okay. If you have fractions, that might mean maybe it wasn't a clean GCF to begin with. Let's take a look at example 2. I need to determine my GCF first. What can I divide out of 14 and 7? I can divide a 7 out. So I'm going to have a 7. Can I divide a letter out or a variable? I can. They all have x's, so I can take out an x. Can I take out 2 x's? Nope, there's only 1 x there. So the most I can take out is a 7x. So let's show our work. If I divide out a 7x, that would mean 14 divided by 7 is 2. Careful here, x to the 4th divided by x to the 1st. When dividing like bases, we subtract the exponents, right? If I take 1 away from 4, I have 3 left. So we're literally thinking of taking them away. And if I have negative 7 divided by positive 7, I have a negative 1. If I have x divided by x, if I take 1x away from 1x, I have none left. So the minus 1 is my final term. Let's take a look at this last one. How about this, you guys? We have multiple variables. So I have a GCF. Let's take a look at our numbers first, okay? I'm going to actually bring out these numbers. I have a 28, a 16, and an 8. Look at the smallest number first. Does 8 go into 16? Yep. Does 8 go into 28? Ooh, no. So 8 doesn't work. Let's look at the next factor below 8 that might work. 7 doesn't work. 6 doesn't work. Okay, think of the factors of 8. Let's just jump right to 4. Why waste time? 4 goes into 8. It goes into 16. And it goes into 28. So 4 is looking like a good number to divide out. Look at our letters. I have, let's see, an x squared. I have an x to the 5th, and I have an x. So the most I can take out there is an x. So I'm going to divide everything by an x. Let's look at our y's. Okay, I have a y, and a y squared. So the most I can take out is a y. Okay, with variables, you're going to take the least or the smallest exponent. You can't take more away from what you have. So my GCF is 4x squared. So let's divide this out. I'm going to have a GCF of 4xy. Parenthesis. Let's divide. If I have 28 divided by 4, that's going to give me a 7. If I have an x squared divided by an x, I got one left over. Y divided by y, hey, that goes away because that would become a 1. Let's look at our next value. I have a 16 divided by a 4. It's a positive 4. X to the 5th divided by x. I have 5 x's and I get rid of 1. I have 4 left over. And a y divided by y, that becomes 1, so I don't need to write it down. Let's look at our last term. 8 divided by 4, it's a positive 2. X divided by x is 1. I don't need to write that down. Or think of the exponents. 1 minus 1 becomes a 0. I have a y squared divided by a y. So I have a y to the first left over. Close your parentheses. So here's what's interesting. If you need to check your work, it is easier to multiply in and distribute than it is to divide out. It's just natural because it's the first thing we learn. So you could check your work by multiplying back into the parentheses and see if you get the question. Let's take a look at this extra example. If you feel like you need more help, then I might recommend writing this example down. You could do it in your notebook or if you have room anywhere on that page of the foldable. First of all, I need to determine my GCF. I'm going to look at my numbers first. I have an 8 and a 32. Does 8 go into 32? It does, so that's going to be my number. Let's take a look at our letters. I have an m cubed and an m. That means the most I can take out is an m. Then I have an n to the 4th and an n squared. Ooh, I can take an n squared out this time. So my GCF that I'm going to divide out of each term is 8mn squared. 8mn squared. So if I divide, let's show our factoring. I have an 8mn squared on the outside. Let's take a look. 8 divided by 8 is 1. You don't have to write it, but sometimes it's helpful. M cubed divided by m, that means I have m squared. N to the 4th divided by n squared would give me 2 n's remaining. Let's take a look at the second term. 32 divided by 8, both are positive. That's a positive 4. M divided by m is 1. N squared divided by n squared is 1 again. So I only end up with a term of 4. So I have my greatest common factor out front, and if I divide it out, I have what's remaining in parentheses. All right, GCF. Once you do some more practice, you guys, this will be so much easier. But just make sure now that you have all your notes, make sure that's good to go. Please make sure that you check Google Classroom, okay? Check to see what work is assigned to this unit or this section. Check to see previous homework. What is your assignment? Please complete that. And then as always, if you need to, check PowerSchool. What are you missing? What else do you need to work on? Until next time, have a good one.